Hello everyone. I'm Qingyu Ruan, the CMT Sub-1G Product Line Manager at Hoperf. You can call me QY. Today, I'll introduce to you all our various models of the CMT Sub-1G product line, as well as their functions and application scenarios. Today's presentation is divided into 7 topics. Topic 1. Chip classification of the CMT Sub-1G product line. Topic 2. OOK modulation single transmitter and single receiver chips. Topic 3. Single transmitter chips with encoding. Topic 4. Single transmitter SoC chips. The single transmitter SoC series chips use an 8051 core. Topic 5. FSK modulation single transmitter and single receiver chips. Topic 6. Transceiver chips. Finally, Topic 7. Wireless transceiver SoC. The MCU core of the series is based on ARM's Cortex-M series. Alright. Let's start with Topic 1. Chip classification of the CMT Sub-1G product line. We'll start with this chart. Our chips are classified in 2 dimensions. The first dimension, modulation mode. It is mainly divided into OOK only and OOK/FSK modulation support. Take a look at this chart. The upper part above the dotted line in the middle is for chips that only support OOK modulation and demodulation. The lower part below the dotted line is for chips that support both OOK and FSK modulation and demodulation. The other dimension is based on their functions. We can further divide them into 5 functional categories. First, single transmitter function. Second, single receiver function. Third, transceiver function. Fourth, encoded transmission or transmitter SoC. And finally, the fifth is our transceiver SoC. This chart categorizes all our various chips and models according to these 2 dimensions very clearly. Next, let's discuss the chip naming rules. First, we are the Sub-1G product line. Under CMOSTEC. All our chips are abbreviated with CMT at the beginning, representing CMOSTEC products. After CMT, there are 4 Arabic numerals. The first numeral represents the product line it belongs to, which means the product line attribute. Currently, CMOSTEC has defined the following product lines. If it's 1, the product belongs to the MCU or SoC product line. If it's 2, it belongs to the Sub-1G wireless connectivity product line. 3 means it belongs to the sensor and signal conditioning product line. 4 means it belongs to the 2.4G wireless connectivity product line. 6 means it belongs to the power supply and power management product line. 8 means it belongs to the digital isolator product line. Today's topic is the Sub-1G product line. So the first numeral of all product models is 2. In the wireless connectivity series, the second numeral is defined as follows. 1 means it's a transmitting device. 2 means it's a receiving device. 3 means it's a transceiver device. So, through the second numeral, you can quickly identify whether the device is a single transmitter, single receiver, or transceiver. Next, let's look at the third numeral. The third numeral mainly indicates the chip's functional category. It is defined as follows. If it is 1, it means the chip is a basic functional device. If it is 5, it indicates support for encoding or decoding functions. If it is 6, 8, or 9, it means the chip has an integrated controller function. Finally, let's look at the fourth numeral. The fourth numeral represents the chip's secondary function, or reflects the chip's resource capacity. Generally, a larger value means more resources, which can be interpreted as a higher specification level within the same product series. After understanding the meaning of the 4 Arabic numerals in our product names, we need to understand the product suffix information. The first suffix is the version information, where the letter X represents the product's version number. For example, common versions include A, B, C, or LB, LC, etc. These are all version numbers of our products. For transceiver products with a controller function, the suffix is labeled as FXX or FXXX. This indicates the ROM capacity of the controller. Finally, let's look at the suffix in the product suffix information. This expanded suffix information indicates the chip's operating temperature rating, package information, and packaging information. Among this, the first letter of the suffix information, E, indicates an industrial-grade temperature specification, with support for temperatures from -40 degrees Celsius to +85 degrees Celsius. The second letter of the suffix indicates the product's package information. For example, S means SOP or SOT package. If the letter is Q, it means QFN package. The last letter of the suffix indicates the product's packaging information. R means tape and reel packaging. If the letter is B, it means tube packaging. After understanding the above naming rules, we will give examples to familiarize you. Example 1, Model CMT2110A ESR. The last 3 Arabic numerals are 110. So it is a basic single transmitter device. The datasheet describes it as a low-cost 240 MHz to 480 MHz OOK transmitter. The version is A. It is an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. Packaged in SOT23-6, and packaged in tape and reel. Now, let's look at the second example. Model CMT2119A ESR. This model differs from CMT2110A ESR only in the 4th digit, changing from 0 to 9, so it is also a single transmitter device. And its functionality should be stronger than the previously mentioned model. Therefore, according to the datasheet description, it is a low-cost 240 MHz to 960 MHz OOK/FSK transmitter, supporting a wider frequency range, with the modulation mode also supporting FSK. The version is also A. It is also an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. Packaged in SOT23-6, and packaged in tape and reel. Let's look at the third example. CMT2210LB ESR. The second Arabic numeral is 2. The third digit is 1. The fourth digit is 0. So it is a basic single receiver. According to the datasheet description, it is a low-cost 300 MHz to 480 MHz OOK receiver. The version is LB. It is an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. Packaged in SOP bait, and packaged in tape and reel. The fourth example is CMT2300A EQR. Its second digit is 3. The following 2 digits are both 0. Obviously, it is a basic transceiver. According to the datasheet description, it is an ultra-low power sub-1G transceiver. The version is A. It is an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. The packaging letter is Q, representing QFN 16. The packaging is also tape and reel. Now, let's look at the fifth example, CMT2310A EQR. Compared to the previous example, the third digit in the model number is 1. So it is an iterative upgrade of the former. It is also a transceiver. According to the datasheet description, it is a high-performance sub-1G transceiver. The version is A. with a temperature range of -40 degrees Celsius to +85 degrees Celsius. The packaging letter is Q, which stands for QFN 24. The packaging is tape and reel. Example 6, CMT 2157B ESR. The last three digits are 1, 5, and 7. So it is an encoded transmitter. The datasheet describes it as a sub-1G00K transmitter with encoding chip. The version is B. It is an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. The packaging letter is S, representing SOP 14. The packaging is tape and reel. Now, let's look at example 7. CMT 2189D EQR. The last three digits are 1, 8, and 9. This indicates it is a single transmitter SoC product with an MCU. And it is a relatively feature-rich specification in this series. The version is D. It is an industrial specification product. The letter Q represents QFM packaging. It is QFN 20. The packaging is tape and reel. Example 8, CMT 2390F64 EQR. The last three digits are 3, 9, and 0. This indicates it is a transceiver product with an MCU. The suffix F64 indicates the ROM capacity is 64 KB. The datasheet describes it as an ultra-low power sub-1G transceiver SoC. The MCU core is Cortex-M0. The flash ROM capacity is 64 KB. It is an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. The packaging letter Q represents QFN 48. And the packaging is tape and reel. The last example is example 9. Model CMT 2391F128 EQR. The last three digits are 3, 9, and 1. This indicates it is also a transceiver with an MCU. The suffix F128 indicates the ROM capacity is 128 KB. The datasheet describes it as an ultra-low power sub-1G transceiver SoC. The MCU core is Cortex-M4F, and the flash ROM is 128 KB. It is an industrial specification product, with a temperature range of -40 degrees Celsius to +85 degrees Celsius. It is packaged in QFN 68. The packaging is tape and reel. We have explained the chip classification and naming rules. To facilitate the introduction of subsequent content, we divide chips into 6 categories based on their functions. Category 1 is the simplest OOK modulated single transmitter chips. There are 2 series of this transmitter, CMT211XA and CMT211XB. For example, the previously mentioned CMT2110A and CMT2119A. Both belong to this series. Category 2 is single receiver chips. For example, the CMT221XA series, CMT221XB series, CMT221XLX series, and so on. All these series are part of our single receiver category. For example, the previously mentioned CMT2210LB, CMT2210LC, as well as CMT2210LH, CMT2219A, CMT2219B, etc., are all single receiver chips. We have a wide variety of single receiver chips. More information can be found by searching through our product catalog. Category 3 is encoded transmitters. This mainly refers to the CMT215X series. For example, there are CMT2150A, CMT2150L, or CMT2157A, CMT2157B, etc. All these are part of the encoded transmitter series. Category 4 is single transmitter products with an MCU, which we abbreviate as TXSoC. It mainly has 2 series. One is our CMT216X series, and the CMT218X series. For example, the previously mentioned CMT2189D and CMT2168A. Both belong to the TXOC series. Category 5 is transceivers. We abbreviate this as TRX products. There are two main product models. One is CMT2300A, and the other is CMT2310A. Finally, Category 6 is transceivers with an integrated MCU, which we abbreviate as TRX SoC. In this series, we have two subcategories: CMT238XFXX and CMT239XFXXX. What are some of the models? For example, models like CMT2380F64, CMT2390F64, CMT2391F128, etc. All these are products in the TRX SoC series. The above classification of our products is based on their functions. If we classify our products based on their modulation modes, there are mainly two categories. Category 1 is OOK modulated products. Category 2 is FSK modulated products. For example, the OOK modulated products include CMT2110A, single transmitter, and CMT2210LB, single receiver. This is a pair of OOK modulated products. If it's FSK modulated products, such as CMT2119A, single transmitter, then this pair is for FSK modulation and demodulation. Of course, compared to OOK modulation and demodulation, FSK modulation and demodulation offer better and more stable performance. Why is that? When is OOK suitable? When should FSK be used? OOK is suitable for low-cost scenarios where communication quality and distance are not critical. Its advantage lies in low cost. Also, its transmission power consumption is slightly lower. The transmission and reception currents are relatively lower than those of FSK modulation and demodulation. For example, when transmitting with OOK, only when data 1 is sent does it consume relatively more power. When transmitting data 0, it actually consumes less power. Therefore, on average throughout the entire transmission process, it requires less power. In contrast to OOK modulation and demodulation, FSK consumes the same power when transmitting both data 1 and data 0. Its transmission power consumption is quite similar. The only difference is the frequency for transmitting 1 and 0. This makes the transmission signal quality more stable. However, this also means it requires higher transmit current than OOK at the same transmit power. Furthermore, FSK demodulation mode is more complex than OOK's. This leads to higher costs for FSK supporting chips. The above summarizes the comparison between OOK and FSK modulation and demodulation. Next, following our product function classification categories, we'll introduce each category one by one, with a focus on the main models in each. The first category to discuss is OOK modulation single transmitter and single receiver chips. We mainly promote two OOK single transmitter chip models. One is CMT2110A ESR, and the other is CMT2110B ESR. For OOK single receiver chips, we mainly promote three models: CMT2210LB ESR, CMT2210LH ESR, and CMT2217B EQR. Note that Q indicates QFN packaging. The previous ones are TES. Below this table are schematic diagrams of these chips, which visually show the chip shapes. For example, CMT2110A uses SOT23-6 packaging. CMT2210LB uses SOP-8. CMT2210LH also uses SOP-8. And CMT2217B uses QFN-16. Note that these chips support different frequency ranges. The transmitter chips cover 240 MHz to 480 MHz. The receiver chips mainly cover 300 MHz to 480 MHz. Of course, CMT2217B is a higher spec product. Thus, its frequency range extends to 920 MHz. Regarding transmit power for transmitter chips, all support up to plus 13 dBm. For receiver chip sensitivity, all are at the -110 dBm level. All 5 chips on the table support standalone mode. For transmitter chips, it's simply data in, antenna out. A very simple working mode. For receiver chips, it's the opposite, antenna in, data out mode. This is the content of Note 2. Additionally, except for CMT2110B, which doesn't support parameter burning, CMT2110A, CMT2210LB, CMT2210LH, and CMT2217B all support repeated burning and updating of working parameters. The function of burning configuration parameters is explained in Note 3. This parameter, burning function, is done via our supporting tools, and will be detailed later. We'll start with the OOK modulated transmitter CMT2110A. Its features: simple to use. Data in, antenna out. Below is a simple reference schematic. A simple schematic. You can see the 6 pins of the chip, including the crystal clock input pin, power negative, D, and the TX pin for PA output. Also, there are 2 TWI bus pins, among which the data pin also serves as the data input pin for transmission. When CMT2110A is in working mode, the baseband data stream enters through the data pin, and can be modulated and transmitted internally by the chip. The baseband data stream can come from an external controller, or from an external encoding chip. It's an extremely simple usage model. Data in, antenna out. Its second feature, CMT2110A supports fractional frequency division, which means it can use a 26 MHz crystal oscillator to achieve a frequency range of 240 MHz to 480 MHz. How to select the desired working frequency point within the 240 MHz to 480 MHz range? This requires our burning tool. Support for burning configuration parameters is our third feature. Parameter burning requires support from the host software interface, which is our RFPDK. Please look at this picture. On the left side of the figure is the interface of our RFPDK host computer. In this interface, users only need to follow these simple steps. 1. Enter the target frequency, as shown in the figure, 433.92 MHz. 2. Set the required transmit power, as shown in the figure, 0 dBm. 3. Set other transmission-related parameters, such as setting the PA ramping time to 0, or other values. Finally, set the time to trigger the stop of transmission. For example, the current setting in the figure is 20 milliseconds. After setting, we can connect the USB programmer to the computer. To program our target chip, click the Burn button on the interface, and the desired parameters will be programmed into the specified chip. After programming, the target chip will operate according to the previously set parameters. Similarly, the receiving device is as easy to use as the transmitting device, but it works in the opposite way. It works in antenna in, data out mode, with the antenna signal coming in here, and the antenna data going out here. This process is the opposite of transmission. Note that CMT2210LB is a low-voltage product, with an operating voltage of 1.8 V to 3.6 V. CMT2210LH is a 5 V product, although its minimum operating voltage is 3 V. Its typical operating voltage is 5 V, with a maximum of 5.5 V. In addition, the CMT2210LB chip supports automatic duty, cycle low, power working mode. and parameters can be set via RBDK and programmed into the chip, enabling low-power scenario applications. Although the 2210LH does not support this duty cycle method, it can still be controlled by an external controller to control its power supply, achieving indirect duty cycle working mode. Similarly, parameter burning for OK is also achieved through the RPDK interface software. Taking the RFPDK configuration interface of CMT2210LB as an example, 1. Set the target operating frequency. After setting the target operating frequency, the corresponding right side will tell you the exact frequency needed. 2. Set the maximum expected deviation of the transmitter. Why set this transmit deviation? Because RFPDK will adjust the receive bandwidth according to the set transmit deviation for optimized selection. If the transmit deviation is small, a narrower bandwidth will be selected, which can bring better sensitivity. 3. We need to set the target rate. This is the rate of the transmitter. For example, the current interface selects 2.4 kbps. This means the rate on the transmitter side is 2.4 kbps. Finally, we can also set the duty cycle working mode, which is this tab. According to the current interface shown in the figure, it sets the sleep time to 3 milliseconds, and the receive time to 2s, which can be understood as long time working, short time sleeping, which is basically a constant receiving situation. Its meaning is to let this device sleep once every 2 seconds. This sleep time for our chip actually generates a reset action. This reset action can enhance the chip's adaptability to the external environment. It can maintain stable operation for a long time. After internal reset, the chip will perform some internal calibration. Of course, for low-power applications, you can set a short working time. Set the working time to be very short, and the sleep time to be very long. For example, set the sleep time to 2 seconds, and the receive time to 10 milliseconds, or 22 milliseconds. This can reduce the average working current. But note that this low-power working mode requires the transmitter's encoding format to match for reliable operation. So, this is a relatively complex scenario, which needs specific analysis and specific parameter settings. Alright, the chips mentioned earlier all support parameter burning. In the R&D stage, you can use the RFPDK host computer software and the USB programmer tool for small-scale testing. So, how to achieve this in mass production? Rest assured, for mass production needs, we can follow these steps. First, set the parameters in RPDK. Then, generate a .exp file via the export button. This file is the target file to be burned into the device. Then, transfer this file to another tool software called Offline Writer Config. Download it to the offline burner. Once downloaded, the offline burner can operate offline. Directly burn the target chip. It supports all models mentioned earlier. Next, let's share the application scenarios of OOK single transmitter and single receiver chips. We'll focus on 2 applications. 1. Car anti-theft device, uni-directional. The vehicle-mounted host houses a single receiver chip, such as CMT2210LB, suitable for 3V low-voltage applications. CMT2210LH is for 5V scenarios. In contrast, the handheld remote uses CMT2110A. Another application is remote-controlled products. For example, a remote-controlled switch. The switch end has a receiver chip, using CMT2210LH, in a 5V system. If it's a 3V system, consider CMT2210LB. The corresponding remote control uses CMT2110A. Above is the introduction to OOK, modulated single transmitter and single receiver chips. Next, we'll discuss transmitter chips with encoding. As previously mentioned, single transmitter chips can work independently. But the baseband data stream needs to come from a controller or encoding chip. Thus, for a simple remote control solution, two chips are required. One being a controller or encoder, and the other a transmitter. The upcoming topic is transmitter chips with encoding, which enable single-chip remote control solutions. In the transmitter, with encoding series, we mainly promote the following models. 1.CMT2150L ESR, 2.CMT2156A ESR, 3.CMT2156B EQR, 4.CMT2157L ESR, 5.CMT2157A ESR, 6.CMT2157B ESR. The table details their specifications. 1. They differ in modulation mode. We will introduce these functions in the following, while others also support FSK. 2. They vary in supported frequency range. Some cover the low frequency band of 240 MHz to 480 MHz. Others cover the full frequency band of 240 MHz to 960 MHz. 3. All have a maximum transmit power of plus 13 dBm. 4. They differ in packaging. Some come in SOP bait, others in SOP 14, and still others in QFN 16. Due to different packaging, the number of buttons it supports varies. For example, under the SOP 8 package, it can support up to 6 buttons. The SOP 14 package can support up to 10 buttons. We will introduce these functions in the following content. Note that there are two special models, 2156A and 2156B, which have a special purpose. Here, it is described that they can support a battery-free transmission scheme. They support kinetic energy power supply. There will also be a detailed introduction in the following content. All these chips can be paired with receivers. They can be paired with all receivers in the CMT221X series. The appearance of all these chips is displayed here. We'll take models CMT2150L and CMT2157L as representatives to introduce the functions of single transmitter chips with encoding. These two models are pin compatible. Both come in SOP 8 packaging. According to the naming rule, CMT2157L is a higher spec model than CMT2150L. What's the difference in specifications? The difference lies in the degree of encoding format support. The 2150L supports 1527 encoding transmitters. The 2157L adds support for user-defined encoding on top of this. Thus, the 2157L is more flexible in encoding. Secondly, both models are low-power products. Simple to use. This can be seen from the block diagram. A SOP 8 chip can directly have 3 I/O, connected to 3 buttons. Connected to 3 buttons. It also has an indicator light, thus achieving a very simple remote control solution. Next, let's talk about the high-end version in this series. CMT2157B is a SOP 14 chip. It has 4 independent button detection input pins. Can directly connect to 4 buttons. Like the CMT2157L, it belongs to the high-spec version of the series, so it also supports custom encoding. It is a single-chip solution that can implement a 4-button remote control. The CMT2156A and CMT2156B mentioned earlier are special function products in this series. Their special feature is that they support kinetic energy powered transmission. So, called kinetic energy powered transmission is actually power generation by cutting magnetic field lines. You can think of it as the principle of a small generator. To transmit, it's an alternating current. And it's a one-time, short-duration AC energy. The chip needs a small power conditioner inside. We need to input AC power to convert it into DC. And then through efficient DC-DC voltage regulation to power the chip's internals. So its special feature is an additional power management module. Next, let's look at some occasions where these encoding devices are used. Here are 3 examples. 1. Low-cost alarm systems. These are mainly used for 2-wheeled electric vehicles. The vehicle end use is CMT2210LH for reception and transmission. The transmitter side matches the remote control with 3 or 4 buttons. Our single-chip solution can handle this. For example, the 2150L is very suitable for a 3-button remote control. The 2157B is very suitable for a 4-button remote control, which can be solved by a single chip. 2. Pager applications. The transmitter of the pager can use our CMT215X series products. For example, CMT2157L can achieve various formats of user-defined encoding and message transmission. The corresponding receiver can use our CMT2210LB or CMT2210LH. And the third application, wireless doorbell. The transmitter of this wireless doorbell is a pressure-sensitive structure. It can be powered by kinetic energy. This structure eliminates the need for a battery. Power is generated by kinetic energy to enable chip transmission. So CMT2156A or CMT2156B can be used. The indoor receiver will use CMT2210LB or CMT2210LH. So far, we've covered these 2 series, including OOK, modulated single, transmitters and single, receivers, and our single, transmitter devices with encoding. Next, we'll focus on the single, transmitter SOS series with a controller. This is one of our main promoted series. We have the following models in our main promoted series. The first is CMT2186A ESR. It is a member of the CMT218X series. This model has 2 packages. One is SOP14. The other is SOP16. But it only supports OOK. The operating frequency range is 210 MHz to 960 MHz. The maximum transmit power is plus 13 dBm. As for the MCU part, it uses a high-performance 8051 core. It has 4 kilobytes of MTP program storage space for user code. In SOP14 packaging, it can support 9 I/O. SOP16 can support 11 I/O, and can be matched with all contact chips in the CMT221X series. The second is another member of the 218X series, CMT2187A. It also uses SOP14 packaging. Compared with the previous one, it adds FSK functionality. The operating frequency range is the same, 210 MHz to 960 MHz. The maximum transmit power is also plus 13 dBm. The MCU resources are the same as CMT2186. But it supports fewer I/O ports, only up to 6. The third model is the highest spec CMT2189D EQR in the CMT218X series. This chip supports OOK and FSK modulation modes, with a better and wider frequency range, supporting 27 MHz to 960 MHz. The maximum output power is plus 13 dBm, packaged in QFN20. It also uses a high-performance 8051 core. What distinguishes it from the above 2 chips is that it uses 8 kilobytes OTP storage space. Thus, it can support a maximum user code size of nearly 8 kilobytes. It also has a 12-bit multi-channel ADC, supporting up to 16 independent I/O ports. The fourth product is a member of the CMT216X series, CMT2165A EQR. Similarly, it supports FSK and OOK modulation. The operating frequency range supports 27 MHz to 960 MHz. The maximum transmit power is plus 13 dBm. Packaged in QFN32. The MCU resources are the same as CMT2189D. But it supports more I/O ports, up to 17 I/O ports. The last one is CMT2168A EQR. Compared with the previous CMT2165A, it has an additional low-frequency receive function. This low-frequency receive function can achieve low-frequency wake-up By low-frequency receive, high-frequency transmit, a two-way communication mechanism is completed. This is our CMT2168A chip. We have discussed the basic functions of these products. Let's take a closer look at some of their functions, resources, and features. We'll start with CMT2186A and CMT2187A. This page lists the MCU resources and RF features of these two models. On the right is a block diagram. And on the left are some of its features. Feature 1 of this MCU. It is a high-performance 1T, 8051 MCU core. This 1T means single cycle execution. 2.A24 MHz RC is integrated inside the chip. It can support a maximum core operating speed of up to 20 MIPs. Its operating speed is 111 UA/MHz. The program is loaded as 4 KB MTP ROM. The typical endurance of this MTP can reach 10,000 times. In terms of data storage, it provides 512-byte XRAM and 256-byte internal IRAM. The chip also integrates a 512-bit EEPROM. And it also supports a 32 kHz low-speed RC oscillator internally for low power timing. The two chips have 3 packages. Among them, 2168A has 2 packages, SOP14 and SOP16. So the 2 packages have different I/O. CMT2187A has only 1 package. SOP14 has 6 I/O. All I/O provided by the chip support I/O level flip, wake up. All levels on the I/O, from high to low or from low to high, can wake up the sleeping MCU. This function can achieve the button function. The chip provides 2 16-bit multi-function timers. These 2 timers can achieve basic timing functions. They can also achieve functions such as compare, trigger, or capture. In terms of communication interfaces, the chip hardware supports 1 UART, 1 SPI, and 1 watchdog. In debugging, these 2 chips support single-wire emulation debugging mode. The debugging interface is very simple, only 3 wires are needed. Power positive, power negative, debug port 1, wire. Can be used for emulation. Finally, the operating voltage of the chip is 1.8 V to 3.6 V. The operating temperature range is -40 degrees Celsius to +85 degrees Celsius. Regarding its RF part, the resources of these 2 chips are the same. The operating frequency range is 210 MHz to 960 MHz. The difference is that CMT2168A only has OOK mode. The low speed rate under OK mode is 0.5 kbps. The upper limit of the rate is 40 kbps. And CMT2187A adds FSK and GFSK with Gaussian filtering. Its low speed rate is 0.5 kbps. The upper limit of the rate is 200 kbps. The maximum transmit power of these 2 chips is +13 dBm. And only 24 mA transmit current is needed at +13 dBm transmit power. The transmit PA adopts a Class E architecture design. Next, let's look at the CMT216X series and CMT2189D. They use the same high-performance 1T, 8051 core. An internal 24 MHz high-speed RC oscillator is also integrated. And this chip's operating speed supports up to 24 MIPs. The storage space is different from the previous 2 models. This chip uses 8 KB OTP as storage space. It can provide nearly 8 KB of user code loading space. Data storage provides 1 KB of data XRAM. An internal 12 KB API ROM is also integrated, which is used to store API functions, and can simplify user code. The inside also integrates a 512 bits EEPROM storage space. Next, there are some unique functions of the CMT216X series and CMT2189D. Such as 7. An internal true random number generator. The inside also supports AES 128 encryption. At the same time, its 24 MHz frequency can be divided to 12 MHz and 3 MHz for operation, which reduces operating power consumption. In terms of low power operation, It also has a built-in low-speed 32 kHz RC oscillator. At the same time, it also supports an external 32.768 kHz crystal oscillator, which can achieve more precise timing results. Similarly, all its I/O support level flip, wake, up of MCU. From PA0 to PA7, PB0 to PB7. A total of 16 I/O all support level flip, wake, up function. It also has two 16-bit multi-function timers. These two multi-function timers can achieve basic timing functions. Functions such as capture and compare output. The communication interface provides one UART, one SPI, and one watchdog. It is also a single-wire emulation interface. Attention please. The operating voltage of this chip is slightly different. The minimum operating voltage of the chip is 2V. The range is 2V to 3.6V. The temperature range is -40 degrees Celsius to +85 degrees Celsius. Next, let's look at the RF performance of CMT216X and CMT2189D. Then its RF frequency will be a bit wider. The operating frequency range supports 27 MHz to 960 MHz. The speed range is similar to the CMT2186A/87A. In ook mode, IT can support 0.5, 40 kbps. In FSK mode, it can support 0.5 to 200 kbps. The maximum transmit power is still up to +13 dBm. And the current at +13 dBm is lower. The typical transmit current is 18 mA. At this time, the MCU is in sleep mode and not power consuming. Its PA belongs to Class E design architecture. Compared to the other products, the CMT216X series also integrates some analog front-end functions, like AFE section. So what's added? A 125 kHz low-frequency receive wake-up device is added. This is it. Besides, a 12-bit multi-channel ADC, supported by both CMT216X and CMT2189D, has been integrated. Here it is. Also integrated is a pair of ultra-low power op-amps. Here it is. These functional units will be further introduced later. We focus on their transmission part. These TXOCs all use the same transmit unit. On the right is a simple block diagram of this unit. It adjusts the N and K values of the phase locked loop internally to achieve different operating frequencies, and then transmits after frequency division. The only difference is, the CMT216X series and CMT2189D support the lowest frequency of 27 MHz to 960 MHz. While CMT2186A and CMT2187A support the lowest frequency of 210 MHz to 960 MHz. In terms of communication rate, when using OOK modulation, the lowest rate is 0.5 kbps. The upper limit is 40 kbps. While for FSK modulation, it is 0.5 kbps, 200 kbps. The maximum power is up to +13 dBm. The architecture of the PA is Class E. There is a difference in transmit current. CMT2186A and CMT2187A are a bit larger. At +13 dBm transmit power, the typical value is 24 mA. While CMT216X series and CMT2189D only need 18 mA. For this TXOC series of products, as it is a product with a controller, so it involves some development tools. This figure shows our development-related tools. In the development platform, we develop via Keel C51. You can use the old Keel 2, or the C51 version of Keel 4, both versions are okay. Note that it should be a version that supports C51. Regarding of the way of emulation debugging, we only need to connect an emulator to the computer and run Keel. This is our emulator. For CMT2186A, we use this emulator. While for CMT2187A, we use this emulator. They are similar with the outlook, but the two are different. So targeted use is required. But they are all single-wire emulation. Very simple. When mass production burning is needed for these TXOC chips, they can be programmed using our offline tool. We need to generate a burning file. Load it into the program via TXOC writer config, and download it to the offline programmer. Then, the chips can be mass-produced. We can also use RFPDK to perform online burning of the programmer. Both methods are okay. Online burning via RFPDK is more suitable for the R&D stage. Offline burning is more appropriate for mass production. Next, let's introduce some application scenarios of TXOC. The first typical application scenario? Take the CMT2186A single transmitter SoC as an example. On the right is its typical schematic diagram. Below this block diagram, we use 4 of its pins as buttons. As a single chip solution for a 4-button remote control. Where can it be used? 1.IT can be used in transmitters to replace the 1527 encoding. 2.IT can be used in transmitters with user-defined encoding. 3.IT can be used in remote keyless entry (RKE) systems for anti-theft. 4. Garage door remote controls. 5. Transmitters in security systems, such as SOS emergency call devices. 6. Door magnet and window detection in security systems. 7. Remote controls for 2-wheeled vehicles, electric bikes or motorcycles. 8. Transmitters of pagers. 9. And also active RFID. For the various remote controls, transmitters, and lock openers mentioned above, we recommend the following products. If the occasion is OOK modulated, with low requirements and cost sensitivity, we recommend considering the use of CMT2186A. If the occasion is FSK modulated and the requirements are not high, with low requirements and cost sensitivity, CMT2187A can be recommended. If targeting all of the above occasions, including high-end applications such as encrypted rolling code and sensor detection, CMT2189D can be recommended. Because CMT2189D has more abundant resources, it can support OOK and FSK modulation, and also supports multi-channel ADC. It can meet the needs of higher-end application occasions. The second application scenario is the ADC detection scenario mentioned earlier. CMT2189D has a multi-channel ADC, which can be used in many occasions requiring ADC for analog signal detection and acquisition. For example, temperature acquisition by ADC, and multi-point temperature acquisition scenarios. For example, temperature probes. This is a temperature probe. It is a multi-point temperature measurement scenario. After the temperature is measured, it is transmitted wirelessly. And this scenario can use our CMT2189D. The chip integrates a multi-channel 12-bit ADC and can achieve multi-point temperature acquisition, then transmitted via sub-1G. The corresponding receiver can display the information. If the receiver uses our receiving chip, such as CMT2219B, it can receive and display the content. The third application scenario is also related to sensor detection and can achieve human body movement detection. The human body movement detection function uses a PIR sensor. It requires an ultra-low power op-amp. Our CMT216X series products include CMT2165A and CMT2168A, which both integrate ultra-low power op-amps. They can directly interface with the PIR sensor. In this pair of ultra-low power op-amp working mode, only 870 Na is needed. After the signal is amplified and sampled by the ADC, and then processed by the MCU, and finally transmitted wirelessly. It is a single chip solution. The fourth application scenario is our PKE, passive keyless entry, solution for motorcycle keyless ignition. The prerequisite for implementing this solution is the need for a low-frequency receiver, which can achieve low-power low-frequency wake-up and low frequency data communication. And then through high frequency response. Complete a two-way communication closed loop function of low frequency receive, high frequency transmit. Among all the single transmit SoC series, only CMT2168A can solve it. It integrates a 3-channel low-frequency receiver. It can receive signals from 3 antennas in different directions. It is also a high-frequency transmitter, with a controller, making it an ideal single-chip PKE solution. In the low-power monitoring state of low frequency, its typical operating current is only 5 UA to 6 UA. When the duty cycle working mode is enabled, the average operating current can be reduced to below 5 UA. The high-frequency operating frequency supports 27 MHz to 960 MHz. The maximum transmit power supports up to plus 13 dBm. It is very suitable. So far, we have completed the introduction of our single transmit SoC product series. Next, we will introduce FSK modulated single transmitters and single receivers. FSK modulated single transmitters and single receivers. We mainly recommend the following 4 models. One is the CMT2119A ESR single transmitter, which is one of our classic products. It belongs to the low-power transmission version. The maximum transmit power supports plus 13 dBm. It is also our best-selling single transmit model. The operating frequency range supports 240 MHz to 960 MHz. The package uses SOT23-6. It supports 2 working modes. One is the standalone working mode with programmed configuration parameters. The other is the controller configuration mode, which uses the TWI configuration method. The second single transmitter is CMT2119B. It is a high-power version of the transmitter chip. The maximum transmit power can reach plus 20 dBm. The operating frequency range supports down to 127 MHz. Up to 1 GHz. The package uses QFN16, with a small size of 3 mm*3 mm. The chip's configuration interface is 3-wire SPI. These 2 transmitter chips can both be paired with our full series of 221X chips and FSK chips. Next, let's introduce our 2 receiver chips, CMT2218B and CMT2219B. Both of these chips use the same package, QFN16, with a small size of 3 mm*3 mm. They have the same frequency range, 127 MHz to 1020 MHz. The receiving sensitivity is -120 dBm for both. The difference lies in CMT2218B only supports the standalone working mode with parameter burning, while CMT2219B only supports the working mode configured via 3-wire SPI interface. Let's introduce these products in detail. First, let's talk about the CMT2119A FSK single transmitter. We have previously mentioned the OOK single transmitter, which mentioned CMT2110A. It is clear that CMT2119A and CMT2110A are related. These 2 chips are pin-compatible products of different specifications. CMT2110A is positioned as a low-end product, only supports OOK modulation, while CMT2119A is positioned as a high-end product, supports both FSK and OOK modulation, since they are pin-compatible. So CMT2119A also has the characteristic of being simple to use. It also supports the straight-through working mode of data in, antenna out. It can choose to operate in OOK mode or FSK mode. It supports fractional frequency division like CMT2110A, supports a 26 MHz crystal oscillator. To achieve any working frequency in the full band range of 240 MHz to 960 MHz. Parameters also need to be generated via RFBDK. Let's talk about the single receiver chip. Take CMT2218B, the FSK receiver chip, as an example. It is a single receiver chip in standalone working mode. So it is also a simple to use chip. Supports antenna in, data out. It also supports fractional frequency division. 26 MHz crystal oscillator. Can support a frequency range of 127 MHz to 1020 MHz. The working parameters are also set and generated via the RFPDK interface software, then burned into the chip's internal EEPROM to enable independent operation. Moreover, CMT2218B supports duty cycle working mode. All duty cycle parameters are generated in RPDK. This mode supports data auto polling. Next, let's introduce the application scenarios of FSK single, transmitter and single, receiver chip products. Here are 4 common application scenarios. 1. Uni, directional anti-theft system. Of course, the previously mentioned OOP scenario is also applicable. When using FSK, it belongs to a high-end version. Uni, directional anti-theft system in FSK modulation mode. For the transmitter end, the remote control uses CMT2119A. The vehicle-mounted receiver uses CMT2219B. 2. Tire pressure monitoring system. In the tire pressure monitoring system, the pressure sensor is the transmitter. It can use CMT2119A. The display is the receiver end. CMT2219B can be used. 3. Pet consumer electronics, dog trainer. This belongs to pet consumer electronics. The dog collar is a receiver. CMT2119B can be used. The handheld device can be used for transmission. So it is a transmitter. CMT2119B can be used. Plus 20 dBm high power version. It can achieve a longer remote control distance. CMT2119A can also be used. With a slightly lower power of plus 13 dBm. It means a relatively shorter distance. 4. Weather forecast station. This is our weather forecast station. In the scenario of this weather forecast station, there is a host with a display screen indoors. This display host is a receiver. CMT2219B can be used. Then outdoors, there is a series of sensor acquisition nodes, responsible for collecting surrounding environmental variables. Send to the indoor host. These transmitting nodes can use our CMT2119B, or CMT2119A. So far, we have completed the introduction of FSK single, transmitter and single, receiver. Next, we will introduce transceivers. As mentioned earlier, we currently have 2 main transceiver models. The first is CMT2300A EQR. The second is its upgraded version, CMT2310A EQR. Since it is an upgraded version, CMT2310A has better performance. CMT2300A covers an operating frequency range of 127 MHz to 1020 MHz. CMT2310A's operating frequency range is 113 MHz to 960 MHz. Both cover sub-G applications. In terms of receiver sensitivity performance, CMT2310A is better. It can support up to -122 dBm. CMT2300A can support up to -120 dBm. In terms of packaging, it has a slightly larger package. It is QFN24 packaged, with dimensions of 4 mm*4 mm. CMT2300A is QFN16, with dimensions of 3 mm*3 mm. In terms of interface, CMT2300A uses 3-wire SPI, while CMT2310A uses the standard 4-wire SPI. Now we will introduce the detailed performance differences between the 2 chips. You can see the block diagram in the top right corner. This is a schematic diagram of the internal framework of the CMT2300A chip. Its characteristic is to use a limiter architecture to realize the receiving chain. The signal first goes through the antenna and matching circuit, enters the chip's interior, after passing through a low noise amplifier, LNA, undergoes frequency mixing processing, then goes through a filter, to the limiter, and then to digital demodulation processing, and finally outputs to the external controller. The transmission circuit is relatively simple. It directly frequency divides through the VCO, and then drives the PA module to send out the signal. It is a low-cost, high-cost performance transceiver solution. The basic features are listed on the left. 1. The working voltage is 1.8 V to 3.6 V. The sensitivity can reach -121 dBm at low speeds. When the data rate is 50 kbps. Its sensitivity is -111 dBm. Its adjacent channel suppression index can reach 30 dB, with a bandwidth of 100 kHz at this time, and the channel spacing is 200 kHz. Its out-of-band suppression index, blocking, has 70 dB at plus or minus 1 MHz offset, with a bandwidth of 100 kHz at this time. The transmit current requires 23 mA at plus 13 dBm. 72 mA is required at plus 20 dBm. The receive current is relatively low, at 8.5 mA. The power consumption in sleep mode is also low. Only 300 mA is needed in deep sleep. If the duty cycle working mode is enabled, the 32 kHz low-speed oscillator needs to be turned on. This increases by 500 mA. 800 mA is required in sleep state. But the FIFO buffer depth of CMT2300A is smaller. It only has a depth of 64 bytes. The interface is 3-wire SPI. But note that it uses a dual-chip select architecture, requiring 2 chip selects. The package is relatively advantageous. It uses a small-sized QFN16 package with dimensions of 3 mm*3 mm. So what kind of application can CMT2300A be used? It can be used in wireless smart meters, smart homes and buildings, industrial monitoring, building security systems, and wireless sensor networks and active RFID. Next, let's look at its upgrade version, CMT2310A. 2310A is our upgrade product of CMT2300A. So where is its iteration? Mainly in its receive chain. As can be seen from the frame in the upper right corner, 2310A has adopted a new architecture. It uses an ADC architecture. This ADC architecture enables 2310A to meet the needs of higher-end occasions, such as narrowband communication. It can achieve better sensitivity at low data rates. For example, this sensitivity. Let's look at the sensitivity at an extremely low rate of 500 bps. That is, at 0.5 kHz, the sensitivity can be as high as -126 dBm. At a low rate of 2.4 kbps, the sensitivity is -120 dBm. Another important performance improvement is reflected in the chip's out-of-band suppression performance. For example, the adjacent channel rejection ratio ACR/I with a bandwidth of 5.4 kHz and a signal bandwidth of 12.5 kHz. The typical value is 60 dB. And the blocking metric is also very good. At plus or minus 1 MHz offset with a bandwidth of 5.4 K. Its suppression effect is 77 dB. Compared with CMT2300A, the transmit current of CMT2310A remains almost unchanged. It is also transmitted directly by the PA after frequency division by the VCO. The transmit current is slightly higher. About 30 mA at plus 13 dBm transmit power. Approximately 82 mA when the transmit power reaches plus 20 dBm. Due to the different receive chain architecture, the receive current is slightly higher than that of CMT2300A. When the on-chip DC-DC module is not enabled, its receive current is about 14 mA. When the DC-DC module is enabled, its receive current is approximately 9.6 mA. The sleep current is similar to CMT2300A, with a leakage current of about 400 mA during deep sleep. If the duty cycle working mode is enabled, and the internal 32 kHz low-speed RC clock needs to be turned on, the sleep current is 800 mA. We have increased the capacity of the FIFO from 64 bytes to 256 bytes. The interface has also been changed to the standard 4-wire SPI, for easier use by everyone. In terms of packaging, due to the iterative upgrade of the chip, its size is slightly larger. A QFN24 package is required, with dimensions of 4 mm*4 mm. CMT2310A and CMT2300A are with similar applications. It can be used in wireless smart meters, low-power wireless wide area networks, Smart homes and buildings. Industrial monitoring. Building security systems. Wireless sensor networks and active RFID. In addition, CMT2310A supports Sun PHYs, FSK, defined in IEEE 802.15.4G. Therefore, it also supports the YSUN Fan 1.0 version. For the two transceivers, we have made some evaluation boards for performance evaluation. The evaluation kits can help for the evaluation. The right side of the figure shows the test EB. This is a motherboard with a main controller and a display screen. There is a 10-pin interface reserved at the top of the board. It can insert the CMT2310A based module. It can also insert the CMT2300A based module. As long as the RF module is properly inserted and the board is powered, the firmware inside the controller can automatically recognize the chip and works according to the preset working mode. Carry out the corresponding work. As for the specific operation of this board, you can refer to our document N241, which contains a detailed introduction. Let's take a simple example. We have a duplex link test mode. There is a pair of boards. We can treat them as A and B. Duplex communication is the information interaction between A and B. A sends information to B first. Then B sends a signal back to A after receiving it. This completes the handshaking of wireless communication. This is a way of two-way communication test. This is equivalent to completing a link test between a transmitter and a receiver. At the same time on the display, it can display the received data packets, signal strength, etc. Next, let's discuss some application scenarios of transceivers. 1. Two-way anti-theft system. The host on the vehicle side needs a transceiver. The remote control is also a transceiver. Two-way communication and handshaking can be achieved between them to ensure valid operation or alarm notification. 2. Wireless smart grid. Each smart meter requires a transceiver to ensure the collected data of the smart meter can be accurately reported. 3. Home or building security. In the security system, we can use the camera as the main device or as a gateway. The surrounding area is equipped with sensor acquisition nodes. These security nodes can be door magnets, infrared motion detectors, smoke detectors, or emergency remote controllers. These application scenarios all use our transceiver products. In the last section, let's introduce the transceiver series with an MCU. There are two main series. One is the CMT238XFXX series. The other is the CMT239XFXXX series. The CMT238XFXX series has two main models. One is CMT2380F29 EQR. The other is CMT2380F64 EQR. In the CMT239XFXXX series, there are three models with 2390F64. 1. CMT2390F64 EQR. 2. CMT2391F128 EQR. 3. CMT2392F512 EQR. These three models. There are distinctions in their RF cores. In the CMT238XFXX series, the main core is Cortex M0. The RF core performance is the same as CMT2300A. The frequency range is also 127 MHz to 1020 MHz. The maximum transmit power is also plus 20 dBm. The receiving sensitivity also reaches -120 dBm. The F29 package uses QFN 32. F64 has two packages, QFN 40 and QFN 48. In the CMT239XFXXX series, in addition to the Cortex M0 core, there is also a Cortex M4 core. The receiving sensitivity and maximum transmit power are aligned with CMT2310A. CMT2390F64 is packaged in QFN 48, while CMT2391 and CMT2392 both use QFN 68. This figure shows the combination of CMT238X. It's actually the combination of MCU core and RF core. This is our MCU's Cortex M0 core integrated with CMT2300A. This is a schematic diagram for CMT2390 and CMT2391. It is a Cortex-M0 core integrated with CMT2310A. This is a Cortex-M4 core integrated with CMT2310A. So we have developed a series of evaluation boards for these transceiver SoCs. Since it comes with a controller, the evaluation board can also be used as a development board for the MCU part. The first one is the evaluation board for the CMT2380F64 model. It has two packages, QFN40 and QFN48. There are two buttons on the board, a buzzer, and a UART to USB interface. In addition, it comes with test function firmware out of the factory, which needs to be used with an LCD shield board. For detailed operations, please refer to our N191 document. This is the evaluation board for CMT2390F64, and the evaluation board for CMT2391F128. Similarly, they come with RF function test firmware. They also need to insert an LCD shield board. For detailed operations, please refer to our N247 document. The RF function test firmware of the above evaluation boards can be downloaded from our company's website. To facilitate users in erasing during the debugging process of using the evaluation board, users can also restore this factory RF function test firmware on their own. Due to time limit, and there are many models in CMOSTEC sub-1G product line, we will stop here today. Looking forward to the next opportunity for our further discussions. Thank you all.